name's Hamilton Klein, and I used to teach code to designers. And now, what is this, once a year? I am trying to make a JavaScript gaming engine from scratch. So I've done a couple of these videos so far, and not a whole lot of action has happened yet so far. And one of the reasons for that is because I'm making a game engine, not a game. But we need a little more action. Less talk, more rock, as they say. So I want to try and do two things today. I want to try to add in something that is pretty specific to games, or I guess graphics, which is a vector object. And then I also want to improve something that we started before and just sort of never did anything with, which is the pointer object. So what we're going to do is we're going to make a vector, which is basically XYZ coordinates. We're going to add the possibility of XYZ, but we're not really going to make 3D graphics, so we're just going to probably stick to using XY, but it's the same concept. And that's going to allow us to manipulate XY coordinates in a way that is easier in game development, in graphic development. And then we're also going to improve our pointer once we have that vector object, and that's going to allow us to do some cool things. And in the process of this, we're also probably going to start creating some math functions, just straight up math. So right now, our game has a debugger that shows us the current position of our XY, and it has a ball that is a circle that is drawn every time that we move around, and our canvas is currently always being rewritten. And then we've got our little graphic up here. We've got our main, which is our run loop, and then we've got a level which draws stuff to the canvas whenever it can. We've got our debugger. It also even has this concept of a quick string that we can just sort of add data to. We have our canvas drawing. We probably won't touch this today, but we'll see. And then we've got our settings. So we're going to be improving our pointer and adding a vector object. Let's see how far we can get today. Now, what is a vector? A vector is a term for any point in space. That can be 2D space or 3D space or 4D space. But that's the term for that. As opposed to saying XY position, you can just say a vector. More importantly, a vector is essentially an array of values that you can then manipulate all at once in similar ways. So let's make a new file and let's call it vector.js, and we're going to add this into our engine. And then inside of here, we are going to export a class called vector. Hooray! There we go. And when we make our constructor for this, we want to spread out however many values are sent into this constructor. So whenever we say like new vector, we want to be able to pass in a whole bunch of values and then create, see, AI is really telling me what it wants. It knows what a vector is. It's got the concept. But we're going to spread out a bunch of parts, however many there are, and then we're going to turn them into an array of values. So what we're going to do is say that this dot parts, so the vector parts, by the way, this could be named whatever you want. We're calling it parts. It's just how we're doing it. Is going to take whatever the parts that got sent in were, and if their length equals 0, we want to return a single array of an XY array. If there's nothing sent in, if it just says new vector, we're just going to say, okay, return a 0, 0 XY coordinate. That one's real simple. If you just want to make a new vector, you can just say new vector, and it doesn't have to get past anything, and it can just return one. However, if what gets passed in is an array, well then let's take the first item in that array and spread it out. So basically what this means is, if we just say new vector, then that creates a new vector that has a 0, 0 XY. However, if we pass in an array, then it will turn that array into a spread of values as the parts of this. We could probably just say that parts equals this, but I usually find that it's a good idea to spread out those values to create a new array rather than just applying the array. That might be mutable. These days I try to be as immutable as possible. Otherwise, we're going to take whatever parts were passed in and we're going to spread them back out into a new array. So the idea is that if there are many parts passed in, then we take that new array that just got spread into an array, and we spread that back out into another array. If there was no parts passed in, then we get an xy of 0, 0. And if there was an array of values passed in, then we spread those out into the array of parts. So what does that mean? We can now also say that we want 1, 2, 3. We can say that we want an array of 1, 2, 3, or we can just do these. Wow, I love how AI is just giving me all my examples. That's fantastic. Thank you, AI. There we go. So that is our vector. And at this point, we could stop, because that's the idea. So basically, we have a bunch of different ways to take any kinds of input in here and spread all of them out into an array. But there's more to a vector than just that. So for instance, one of the things we can now do is we can loop through that array of things and we can manipulate it. So for instance, we could say that we want to add an object with parts. The presumption here is that we're going to add a vector to a vector. And then what we can do is we can return a new this.constructor, and we can spread out the parts by mapping onto them a singular part, its index, like this. Okay, so basically what we can do is move a position in full 2D or 3D space all at once. You don't have to do those things one at a time. You don't have to say add x to x and add y to y. You can just add to the vector by passing in another vector. And it simplifies the concept of how you want to add value to a position. Now, this doesn't mean it changes to that other position. It gets added by that position. So if we have a position at 1, 1, and we say add a position of 1, 1, it is now 2, 2. But if we can also say add a position of -1, and it's now 0, 0. So this is the basic concept of a vector object, is that you can now manipulate all of the parts of the xy in a very simplistic manner. Now, there's a whole bunch of these functions that we could develop at this point. We could do a subtract. And at this point, AI knows kind of how I've developed this, and it's going to try and develop it in a very similar manner. It's going to use, before it said P and I, and now that it knows that I want part and index, it's going to continue to do that. It also tried to shrink these values down into a small space, and now that it knows that I want a little space, it's willing to give me a little space. So the AI is pretty smart about trying to go by what you want. Now at this point, it says that it wants to multiply by a scalar. And that's great. Now, you can name them sort of however you want to name them. I'm going to talk about why this is called new this.constructor in a little bit, rather than just anything else that the AI wanted me to do at the beginning. But for right now, understand that there's a reason for that. But AI has generally made all of these concepts before. It's just made them in different ways before. But when it comes up with names, those are probably the standard names. Like, it knows I want to multiply, and it knows that this is supposed to be called a scalar. And a scalar at that point is going to be a floating point value, so a percentage of some kind, a rational number, if you will. And so that's what this is going to do, is it's going to multiply the value as opposed to just add it. Real simple stuff, okay? What does A want me to do? Divide? I'm going to skip divide. I'm going to skip to lerp. Now, what's cool is that lerp knows kind of what I want from that. In this case, lerp has called this t right here. We're going to call this, again, a scalar. A lerp is moving a distance a little bit at a time. In other words, taking one position that you want to be at and moving it a percentage of the way there. That's the way a lerp works. So as opposed to this, which adds one position to another position, or as opposed to this, which multiplies a position, this is basically saying that I have my position where I am. I want to be at this position over here, and I want you to take me a percentage of the way there. That's the way that works. And lerps are extremely useful throughout graphics and video games in order to set the movement speed of something. Okay, what else can we do? What else does it want to give me? It gives me distance, which is great. But we can also just get the magnitude. We have normalize, which is extremely useful. Yeah, let's do the dot. We could do the cross, and then we could also do a clamp. So this is a way of setting up a rectangle where ships can live and they can't go outside of that rectangle. Now, there are so many more things you could do with a vector, and if you don't know what a magnitude or a dot product or a cross product are, well, you might want to go take a game programming course, because this is not necessarily teaching you game programming or the terms. And in fact, when I was originally making these, I called these all kinds of other words until I actually found out what these words were. So these are pretty standard concepts. And, you know, if you want to go find out what all of this stuff is, I highly suggest you find out the reason that you would want a dot product or a cross product or anything else going on. This is only doing X and Y, though. I don't want to do that. Hold on. I want to do a new... Yeah. That's what I wanted. Okay. Now, one of the things we can do at this point is to add some getters and setters for this. So, for instance, trying to get the vector.parts 0 is less useful than just saying get X for this. And that's where this comes in. So we can do this. Whoop, whoop. There we go. So now we have our get XYZ, which is fantastic. And then we can do our set X, Y, and Z. So at that point, we can get the XYZ, which is, you know, our part 0 and 1 and 2. And then we can also just set that value to something else. And this allows us to essentially say that if there is a new vector, then we can say dot x equals 5. And that basically sets the x by doing a setter. We are now setting the value of the x of this vector. Okay, so just having this was enough to sort of simplify all this. Now we have all of these extra methods that this vector can use. And at this point, let's do just a couple of things that are nice that aren't necessarily standard in a vector object, but I'm going to do them. I'm going to do a get xy. You know what? Never mind. I'm not going to do get xy. I am going to make a get copy, and get copy is going to return a new constructor of this thing's parts. So basically it will, so if I say vector.copy, then it will return a new constructor with these parts so that it is essentially, this copy will be the same vector, but it won't be the same array pointer. It will be a new object in JavaScript. Okay, now what I'm going to do is I'm going to make a gap x, and this is going to take another vector, and it's going to return the distance between these two vectors. And if we then create a gap y and a gap z, then we can basically find out how far away this vector is from that vector. The other thing I'm going to do is I like to have small code sometimes, so I'm going to make a smaller thing. And so what I'm going to do here is I'm going to export another class called vec2, and it's going to extend the vector. And although it wanted me to do a whole bunch of extra stuff, I'm not actually going to do any of that extra stuff. I don't think you actually need to do that at all. You just need to do this, because basically the idea here is that vec2 is going to be the exact same thing as vector, and vec3 is going to be the exact same thing as vector. The implication here is that if it's a vec2, it's only going to be using 2 of the values, and if it's a vec3, it will be using 3 of the values. And they are exactly the same, they are just now implied to be different. That's all. At that point, I'm also going to export a const called vec2. And this is actually going to take all of its parts and make a new vec2. And I'm going to make a const called vec3. And I can now say that there is a new vec2 of something like this, right? But then what I can also say is that there is a vec3, and it just gets called as a function. So this gets called as a new instance, whereas this just gets called as a function. And I can just say, make a function right here. And sometimes it's awkward to write a new instance in the new instance way, and sometimes it's easier to just write it in a functional way. So if you just want to write it in a functional way, you can just write it in a function. So earlier, I mentioned this new this.constructor thing up here, and There's a reason for this. When you're making objects like this and you want to duplicate them, you will probably in the beginning just type out new vector. Why would you do something else other than that? However, we also made this code down here that extends the vector and creates two different versions of the vector, the vec2 and the vec3. And the fact of the matter is that if we were to have a vec2 and it used one of its methods that called new vector, the result would no longer be a vec2, it would now be a vector. However, by using new this.constructor, whatever the initializer of this object is, it will produce another one of that object type. So now, if we do a vec2.subtract, the result will still be a vec2. It will not be a vector on end. It will be still a vec2. And that's the reason to do that. Also, I don't think I need these gap x's. Those are a holdover from old code. And really, the distance already serves this purpose. Instead of doing gap x, we would just do distance.x. So, yeah. You know what? For good measure, let's do a couple more things. Let's go ahead and add in our parts, just so that we can have that clearly defined up top. But then let's also, I'm going to change my mind. I am going to add in this get xy. And that we're actually just going to create an xy object. And then we'll do the exact same thing with an xyz. And sometimes it can be useful to not export the whole object of a vector with all of its implications and all of its kind of hidden values, and instead simply output a simple object from this, especially for purposes of, for instance, printing out data like something up here. It's, yeah, there we go. Okay, that's our vector. How far into this are we? We're 26 minutes. I'll bet I can cut out about 5 minutes of ums. We're 26 minutes into this. That was a lot. We added a whole bunch of stuff here. We now have a vector object that's going to allow us to do all kinds of good information about our positional math. And now what we can do is we can go to our pointer, now, which is a positional concept. We're calling this pointer. But what we might as well do is also include some just kind of all inputs. This might as well be our input.js, but we're going to still call it pointer.js because that's the main point of it. Let's add some extra stuff to it just for fun. Okay, right now we've got an x and a y. We're going to set those to 0 right off the bat, which is what we can do over here. And then I don't have to do that here. I'm going to also create a static called keycodes, and we're going to do button inputs as well. And then I'm going to add a static that is called scrolling, and that's going to equal false. And then we're going to add a static for buttons, and buttons is going to equal false, false, false. And depending on the mouse that you care about, you could go up to like 6 buttons. I don't know. Some mouses have lots and lots of buttons. We're going to make some touches, because why not? And we're going to make a static delta, which is actually going to be, which should probably be a vector. I'm going to say that's a vec3, which has imported from vector, but as you remember, the first time you import a file into a file, it doesn't remember that it needs to import it as vector.js. So remember to do that. And let's save. Is our code still working? Our code still seems to be working. It is still live, so we're still good. Did we save this? We saved this. Okay, good, 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 good. Actually, before we go too much further, we've got this. I'm just going to git. Let's git commit added vector. There we go. Don't forget to git, you guys. Okay, so let's add a whole bunch of event listeners. Key down, sure. Let's add key up, sure. Let's add wheel, sure. So it saw the things that I've added here, and it's like, okay, I got some ideas. Let's add in a touch move, because we care about touches in this world of phones. So we got touch move, touch start, touch end. Cool, 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 cool. And then let's do context menu. Basically, if we're making a game, we probably don't want somebody to be right-clicking and being able to see the things that are in right-click. So let's remove that entirely. And let's, maybe we want to make our own right-click, you know? Maybe that's the kind of game we're making. So let's just get the event, and let's prevent default. And let's also just return false for good measure. That's always a good idea. So let's prevent whatever default of context menu is. And now right-clicking does nothing. All right, we've turned off the right-click of this game that we're presumably making in our game engine. So right-click won't accidentally right-click unless you want to turn that back on and do something with it. Let's make ourselves another class. Let's export a class called a point. We probably don't need to export this at this point, but we're going to do it anyways. This thing is going to have a constructor with a position, and then it's going to have a this.x and y of the p.pagex and the p.pagey. I feel like this is going to get past an event. We should call that event. That's a better name. Let's call that event. And then we're going to make an ID equal e.identifier or 0. We're going to make a this.startx and a startY, and then we're going to do a this.t equals date now. This point is going to allow us to save an event position and then recall it later for reasons. Now, let's go down to our mouse move, our mouse down, and our mouse up. Because right now what we're doing is we're getting this dot position, and we just didn't do anything with this. We set the position of the pointer, and that was it, right? And as you might recall, inside of our main, we are initializing our pointer, and then inside of our level, we are making a bug for our pointer. That's how we're getting those things on our screen. So we are having a position, which is an XY, which, yeah, okay. And what we're going to do is whenever we mouse move, we are going to e.prevent default. So whatever the mouse move was going to do, we kind of want to turn that off. At that point, we are, in fact, going to make our this.pos. However, I think that this could be as simple as making a vec2 of our xy. Let me see what happens if I do this. Does that break? I think that broke. Let me bring up this. Vec2 is not defined. Well, let's bring in vec2. Did that bring in vec2? We've got vec2. Let's save. Okay, we've got our vec2. And we are... Is that correct? That's right. Hold on, is that right? Sorry, I didn't do this with vec2 before, and it's working perfectly, and I didn't expect that. But it works perfectly. Excellent. All right, let's do another vec2 right here. Excellent. That worked perfectly, and I am so happy. Okay, cool. So now we are getting our position. We are setting it with our vec2, but we are actually getting it by just returning an XY object. That's fine. Okay, cool. Excellent. All right, now let's do our mouse down. On mouse down, let us set this buttons e.button equals true. Actually, let's set it to a new point. There we go. Let's set it to a new point. So this button is going to get set to a new point anytime a mouse down happens. Now, we should be able to go back over to our level, and we should be able to make a new bug for buttons, and we should be able to say buttons. Okay, so now what we have is buttons 0, 1, and 2 is false. But if I click a button, it gets set to an object. If I click a different button, like the right click, it gets set to a different object. And if I click my scroll wheel, I get that. Now, my mouse actually has like 17 other buttons, so I could keep adding buttons to my button array. But for right now, it's actually not a button array, as we saw. It is, it is a button array. It is just 3 buttons, though. If I click other buttons, what happens? Oh, that was too much. So many buttons, so we can keep clicking buttons, and however many buttons we have on our mouse, that's how many buttons we have. So that means that we can now see the position of where I clicked. I can see the time where I clicked. I can see the X and Y of my click and all of that good stuff. Mouse down now has the position and the type. Well, it doesn't have the type of click, but we're assuming that if it's 0, then it's the left click. If it's 2, then it's the right click, and if it's 1, then it's the middle click. We just know that about most buttons. Most buttons, that's the way they're going to be set up on mice. So now let's do the mouse up. Also, let's do a prevent default on this, and then let's do a prevent default on this. And now for this, what we're going to do is set this dot buttons, e.button to false. So if I click my mouse button and then I let it go, it goes away. It doesn't stay there the whole time. So now when I click it and hold it, it stays. And when I click and hold the right button, it stays. And when I click and hold the middle button, it stays. And I can even do multiple buttons at once. So I can see anytime that there's 2 buttons. So my pointer now has the concept of anytime any one of my buttons are down. And it even has a bunch of information about them. It has its start X, it has its current X, and it has the time when it was first clicked. So let's make a new function called static get has dragged. And has dragged is going to return if this dot buttons sum, if sum of the buttons have a b equals b and this dot pos dot x and y, or if this dot touches, you know what, we'll do that later. We'll add that in. Okay, so let's make another bug, and this bug is going to be for has dragged. And it's going to be for pointer dot has dragged. So has dragged is currently false, but if I click, you can see that now when I am dragging the mouse, it is knowing that I have. Cool. We now have a concept of whether or not the position has dragged. So on mouse move, if not this dot has dragged, then we're going to say that this dot is dragging equals false. And on mouse up, wait, am I on the wrong thing? I lied. That's down here. That's on mouse up. On mouse move, I want if this dot has dragged, then if not this dot is dragging, then this dot is dragging is true, like this. Now we can come over here and we can actually pass in an object of has dragged. At a certain point we could probably just spread out the pointer into this value, but it actually has value of separating these out onto separate lines rather than unique names, rather than having them be one line. And then we'll do is dragging as well. Why does it not like that? Because this needs to be like that. There we go. All right, so now we've got an is dragging, and is dragging only gets set once the position changes. So is dragging is false because I'm not currently dragging, but as soon as I move, is dragging is true. So now we have this concept of if button moves, we know that it is currently dragging, so it is in a new position, and therefore we have a whole bunch of information for the mouse. Now you might be thinking to yourself, Hamilton, I didn't want to make a game with a mouse. Well, then this part of the tutorial is not for you. But there are plenty of uses for mouses and mice and meese, and so this is going to be useful to somebody, so shut up. Okay, now then, let's do our touches. Let's do our static touch move. So what we're going to do is we're going to let our target touches equal, we're just going to spread this out, from our target touches of the event. Then what we're going to do is we're going to take our target touches and for each through all of them, and we're going to say that touch is going to find our touch by that, and then if that touch already existed, okay, so you got to know something about touches, I guess. I should explain this for a little bit rather than just doing it. touches are weird, and they are a group. They are a group of touches on the screen. I have a pen screen right here. It's not a touch screen, but it's a pen screen, and it turns out pens are considered a touch. And if I touch on the screen, there are multiple touches that can happen, not just one. There's oftentimes on some screens up to 10 touches that can happen, and so they happen in an array. And the problem is that when the buttons happen, right, when the mouse buttons happen, it knows exactly which button it is. It knows whether it was the first button or the second button. The buttons are always the same. But when touches happen, the system doesn't know which fucking finger touched. It doesn't know which one, so it's just got an array of touches. It does know that, generally speaking, it's pretty sure that when one finger touches here and one finger touches here, it knows that if this touch continues and moves, it's pretty sure this is that same touch. And if this one touches and moves, it's pretty sure this is that same touch. But if they get too close, it can get confused, and if one lets go, it's just like, touch ended. I don't know which one. If that finger goes back down, it doesn't know it's the same finger. It just knows an old touch ended and a new touch began. That's all it knows. So this array is a very amorphous concept. There are target touches, there's current touches, there's a whole bunch of touches. It's really annoying. So if it finds a touch that already existed, we're going to update its X and Y with the current page X and Y. But we're going to not update, so we're going to update that point's X and Y, but we're not going to update its start X and Y. So we will know its position, okay? At that point, then if this dot has drag, yes. However, what we're also going to do is we're going to update the position with a vector of that page X and that page Y of the first touch. So we're just going to grab the first touch. We're not going to try anything else. By the way, touch move happened because touch is happening. So there's never not going to be at least one. If a touch move is happening, at least the first target touch is going to be in existence. So we don't have to worry about that. At least one is going to be there. Otherwise, touch move wouldn't have fired. Okay, so we've got our touch move. At that point, what we can do is we can do our touch start. Let's see what it got here. It's got e.preventDefault. I'm actually not going to prevent default on touches, and that's because touches are weird, like I said, and we actually don't want to prevent their default. We actually want their default to happen, and that's just how that's going to have to happen. All right, so we've got our touches equals that. So let's do a const touch equals e.changed touches 0, and then we're going to push a new point of that touch into our touches array. Yes. So what we want is to push our touches in there because we want to control them and we want to update them as opposed to rewriting them. Whenever a touch event comes in here, it basically completely rewrites this and it doesn't know how long it's been there. It has no concept of length. We want concept of length in our thing, and so that's why our points have a start X and a start Y, and then we update them. We don't completely replace them like the event handling of the browser is. So what we're going to do here is actually just take our touches and set that to 0. So whatever your first touch was, that's where your position is going to be set if you're touching. Should this be done this way? I don't know. That's how we're going to do it. Our position is always going to be your first touch. Never just all of your touches, just your first touch. There we go. Okay, so we've got our touch start, and now we're going to do our touch end. Let's save that. Let's go back to our level. And let's add our touches. Okay, so we've got touches. Let's take our pen and draw on the screen, and hey, I've got a touch. And when it lets go, it lets go. Hey! So my pen touching on the screen is a quote-unquote touch. If I go into device mode, then I can see that those are also considered touches. Although my X and Y is wrong. It's undefined. What did I do wrong? It's a good thing we tested this. Was that also the same for, hold on, is that also the same for here? Yes, it's undefined. So on touch start, this is wrong. This should just be, was that always wrong in my old code? Nope, it wasn't. I just didn't notice that this had changed. There we go. Okay, a pen, A, always a good, why is that down there? Are those backwards? Did I get these backwards? I got these backwards like a dummy. Look at that. Look at that. It's a good thing we tested these things. Hey, there we go. Now, let's see here. Is dragging is false. You see that? Is dragging is false. That's because of something that I started to do and then stopped doing because I hadn't done enough of it yet. Down here with has dragged, we want to know if this is also based on touches. And so we want to do the exact same thing with this.touches. And so now, okay, hold on. Do I have this right? I always have to check the code that it gives me. Okay, hold on. Okay, so at the moment, when we click and drag, our button position is not updating because we're not updating the button on move. Go back up to our mouse move. Okay, we're gonna have to update this code just a little bit. So, on mouse move, if this, then this buttons, if b.x equals, yeah, save. Okay, so now our is dragging is never getting set. Got it. And is this updating all of them? Yes. Okay, there we go. Excellent, excellent. Now let's come back down here, and we're going to go back to what they had before with b.startx and b.starty, and then t.startx, and then t.starty. Let's save that. Let's come back in here. Hey, is dragging is true. Yay! Hey, cool. Let's do our point. Hey, look at that. That now works correctly and better than I had it in my code. I just fixed something in my code. Hooray. Let's add a wheel. Static wheel is going to get an event. And then it's going to ePrevent, and this dot scrolling equals set timeout to be this dot scrolling equals false, and this dot delta. Oh, wait, no, I liked what you did. Wait, come back. Wait, what? No! Hey! No! Yes, that's what I want. This dot delta equals a vex3 of 0, 0, 0. Yes. That will set its XYZ to 0, and we're going to set that to happen every 200 milliseconds. Basically, what we want to do is, as we're scrolling, we want to be able to turn off our things. As we were talking about before, in the browser, that when events happen, they tell you what happened, but they don't tell you when they stop or when they end or anything like that. So this is going to be able to tell us when scrolling has stopped within a reasonable amount of accuracy. We don't want to check this too much, but we want a reasonable amount of accuracy. Then what we got is this dot delta equals vec3, but it's giving me a weird, that's not what I want. I want e. Hey, there we go. Delta XYZ. This is the way the wheel is going to work. So let's go do our wheel. Is that what we said? Is that what we said? Wheel? No, delta. Okay, so now we have our wheel. And when we scroll, we should be able to see when we scroll and when it has sort of stopped working. So we can see scrolling, stop. Scrolling, stop. Scrolling. We can even, like, my scroll has a quite intense scroll on it. It's actually still scrolling, and we can sort of see the direction that it's going. Now, I wonder if my particular scroll wheel is too intense for this, but I think we need a static is scrolling. We also need the static is dragging to be set and defined. Okay, so if, actually, I'm going to set this up here. I want to set if this dot scrolling clear timeout. Yeah, and reset this. That's what we want. Man. Okay, let's try this again. Hey, there we go. That's better. It wasn't clearing the timeout. That's what we wanted. Excellent. Okay, so if we're scrolling, we know that we're scrolling. We know the direction that we're scrolling because it would be negative if we were going up, and it would be positive if we were going down. So we've got our scroll position. Hooray! Excellent. Let's delete that because we don't need that. Let's save. We've got our wheel. Excellent. Now let's do our key codes. Let's do static key down. This.keycodes e.code equals true, and static key up. This.codes equals false. Let's go back over here and let's do key codes. Wait, key codes is internal. So let's just say that the static get key codes equals return this.keycodes, And then let's get key codes. All right, save, refresh. All right, we've got key codes now. So that means that when I press a key, I now know that I pressed that key. I know that I pressed the F key. I know that I pressed the space key, or the control key, or the shift, or the alt, or the... Nope, it doesn't know the... Oh, metal left! Oh, it got it. Yay! All right. Now, it knows when they're down, and it knows when they're false. Does it have a whole bunch of these suddenly going? Yeah, that's fine. This basically allows us to set up a game where we have a good idea of the keys we expect someone to be pressing, and we can look exactly for them. This is an array. It's an object, which means that at any one time we can see if metal left is there. And if metal left is there, then it's either false or true, and if it's not there, then it's false. It's a really simple check to be able to do, and at that point, we don't care whether these stay there. I mean, I guess we could unset them on key up, but I don't know that that gets us anything necessarily. There can only be so many keys in here. It's not that big of a deal. Could you have used, what did they have? They had key, I think, there for a second? What's that? That's just the key value. However, I guess you could do that however you wanted to do. But at that point now, we can, know if somebody is pressing the WASD keys. We can know if we're doing multiple at the same time. So we can see if they're all three down at the same, if it's Control W. Whoops, that's not what I wanted. Did I just delete the window? Like a fool? I think I did. Like a fool. All right, so we now have all of that good, stuff. Look at that. Our debugger is now quite filled out. We have keys up and keys down. We have mouse up and mouse down. We have touch. We added touch. We added wheel. We added all kinds of good stuff. It's fantastic. Is there anything else that we can do that's worth doing here? I don't think there is. I think that's good. If we wanted to, something that I've done sometimes is we can just say window.pointer equals pointer. And that means that then over here, you can just access the pointer anytime you want. And it's got this. Now, that's not necessarily useful to us because the pointer itself it's just accessing the pointer like object. If you then said, let's do an export, and let's just return a whole bunch of values. And now we can say pointer.export, and we can just get a whole bunch of the current values of whatever they are. If something had been set, then we could just see a whole bunch of those values if we wanted to. If you wanted to see some stuff that was there, then you could see it. And we now have a pretty good pointer object. Took us an hour and a half to write it, but that's a pretty good pointer object. Will we add more to this? Possible. Could you start making a whole bunch of games based on this stuff? Yeah, I think you really could. I think you could start making some games of like, this is here and this is here. You now know wherever the pointer is. You know anytime that a mouse is down. You know anytime that a key is down. If both of these things need to be true at the same time, you know that both of them are true at the same time. You can see whether or not you've moved since the button was clicked. You have all this information, so much information. We know when the wheel is going. We know when mouse touches are happening. We've got all of our inputs. Now, we got a lot of our inputs. I can't think of too many other inputs we might want to know about, but now we know about lots and lots of inputs at any one time. And inside of our level, we know about them at any one time. I could say that red, that the fill style here is red, right? But if pointer dot buttons 0 is not false, then I could say that it's red, otherwise it's blue, right? Okay. Oh, blue is not defined. That's a string. Okay, so now my circle is always blue, but if I click, now if I click right click, nothing happens. But if I click left click, then my circle is now red instead of blue. So normally it's blue, but when I'm clicking, then it's red. Look at that. There we go. We're on our way. We're on our way to interaction. So now we have the concept of a vector, which is positional math. Inside of space, we have the concept of a 3D vector if we want it, but we'll probably be using a 2D vector for the most part in any games that we make with this particular engine. I don't know, maybe you want to make some 3D games, go for it. You got it. You got the ability now. I probably won't do that, but here we go. There we go. That's something. That's not nothing. That's something. That's good. That's a good start into any game that you might want to make. We got some positional math on our vectors. We got our pointer finally having not just pointer values, but key codes and all kinds of other stuff. This pointer is now quite useful. Could it be better? Yeah, I did a bunch of changes right here, right now. Will you improve on this? God, I hope so. I hope you'll share if you improve on it. There are probably tons and tons. I already know other ways that I could improve on this or add things to it to make it even more useful. There's a lot of things that we could do with this, but I think that that's a good place to stop for now. I am going to git add. I'm going to commit added all kind of stuff. Should this be more specific? I don't know, probably. But there we go. Yeah, I'm happy with that. Will I do another one of these videos? God, I hope so. There's so much other stuff that we can do, that we could actually make a game with this engine. At this point, we could actually make a game with this engine. Could we make a game? Yes, we could make a clicker game. We could absolutely make a clicker game with this engine. Should I do that in the next video? I don't know. There's so many other things. We haven't built timers. We'll probably need to build a timer. We don't have the concept of sprites or anything like that that we'll need. We didn't touch on maths, which I thought we were going to. Our canvas is pathetic. So there's so many other things to make. I can make many more of these videos, and I hope I do. Maybe we'll make a clicker game in the next one. Actually, maybe we'll make a timer and a clicker game in the next one. That could be fun. All right, that's all. The game engine is coming along. We've got a lot of fun things happening, and maybe I'll do another one. If you enjoyed this, thank you so much. If you commented at all on any of these videos, thank you so much. If you found this useful, I hope you did. That's all I have found it useful to make these things, and I have found it useful to try to make these things, even if other people have made them. It's useful to do, and so I hope that you all are doing. Yeah. Thanks a bunch. Have a good evening. Maybe I'll see you again.